So there are lots of things we can do in Unit 1 with the help of this graphic calculator. So let's start with something that is very popular, and that is NSolve. So as we all know that NSolve is when you go to menu, algebra. NSolve is basically, we use NSolve to solve equations, whether it is a polynomial equation, non-polynomial equation. For polynomial equations, we have a beautiful tool here, brilliant tool, roots of polynomial, polyroot finder. Polynomial tools, we can find real roots, we can find complex roots. If we have linear simultaneous equations, we can solve it using simultaneous equations. But whenever you have two different kinds of functions, we cannot use these polynomial tools or simultaneous equation solver. So another option we have, there are lots of options. We can do it in numerous ways. Numerical solver is one of those options. We can do it graphically. We can use it with the help of table. We can do it by iteration. But this is straightforward. So we can use numerical solve. So numerical solve is used when you have any kind of equation you can solve with this. Even polynomial equations we can solve, or when equations are non-polynomial, like maybe exponential, logarithmic, trigonometric, etc. Numerical solve. So numerical solve straight away. Either you can go to menu. Let me show it to you again. So you can go to menu, algebra, numerical solve, and click. So you get and solve. Now, beauty of this calculator, another beauty is, as you all know, you can type off. So if you're using emulator, or even in your handheld, you can type. Just type and solve. You see till NSOLV, it is italic. The moment you type E, it is a normal font. It means something. Now, in this one, the syntax is you write your equation, comma, you define your variable. So, so how it looks is, for example, you're solving an equation, x raised to the power of x squared is equal to 4. So just write x squared is equal to 4, comma, define your variable, out your variable is x, and enter. When you enter, you get your answer. Now, this is very, very effective when you have only one solution. What if you have more than one solution? Then how do we get those solutions, and how do we use it effectively? For example, this x squared is equal to 4. So when you write equation, comma, variable, that gives you one root that is closest to 0, 0, or say more than or equal to 0. So closest to 0, 0, that is origin, and more than 0. So x squared is equal to 4 will give you x is equal to 2. Now, if you like to see other root, or let's do one more equation and solve. This time, let's say we solve x squared minus x minus 2. So we can say x squared minus x minus 2 minus 2, comma, where is comma? Comma is here, comma x. When you enter, okay, can someone tell me what is missing here?
Equation is missing.
Exactly.
Yeah.
Equation.
The expression is not an equation.
Absolutely. And you see, there is, if you go to menu in algebra, there is one more tool that is called polynomial tool. Out here, when you type, it has to be expression, not the equation. In NSolve, it has to be the equation. So what we do, we need to copy it again. Either you type it again all over, otherwise you just select it and enter. It will be copied down here. So just make it is equal to 0, is equal to 0, and enter. So what do you get? You get one answer. Which answer? That is closest to origin and more than 0. Closest to origin or more than 0. Now this is -1. So -1 is closest to 0. So another answer may be positive, but it is not closest to the origin. Now how do we get another answer? If you see, the product of roots here will be negative because this is x squared minus x minus 2. So another answer has to be positive. So you can command your calculator, you can change your syntax. How can you change your syntax? There are numerous ways to do this. So another syntax out here is you write your equation, then you write x, then comma. If it is, if you type a number here, let's say if I type 1, then your answer will remain. Your answer is x squared minus x minus 2 is equal to 0 and x comma 1. So the root that you're finding, so this is the lower limit. When you type x comma 1, this 1 will be the lower limit of your answer. So any answer that is more than 1 will be here. And this can be done even outside the bracket. How can we do it outside the bracket? X, just go out of this bracket and you put the condition out here. This is the condition, or this X condition could be x is more than or equal to 1. So you get 2. So these are different ways in which we can use and solve when you have multiple solutions. So if you do not put anything, if you just write your equation comma x, means you will get one answer that is closest to 0. And if you put a condition here like x comma 1 in this one, then this one will be the lower limit. You can also specify that you would like to have an answer between two values. For example, if I just copy and paste it again, if you put x1 comma 1.5, no solution find. So this you're commanding your calculator now, find me a solution that is between 1 and 1.5. There is no solution here. We know that one answer is 2. If we change it to 1 comma 2, then you'll get your answer as 2. So this 1 and 2 is between 1 and 2 inclusive. So this is how we can really use it very effectively. So I hope everyone has calculator here. So maybe you can try one question here. Let's do this one and solve. And my equation I can change to now x squared plus 5x minus 25. Simple. X squared minus 5x, x squared minus 5x plus minus 25 minus 25 is equal to 9. Is equal to 9, and my variable out here is x. Now, if you just enter, you get negative 3.84, and this is a quadratic equation. It will have two answers, and if you see again, another answer will be positive because this is simplified to x squared minus 5x minus 34 is equal to 0. So product of roots is negative. So what we can do is we can just put a condition here. And that condition will be that optional syntax you can put where x is positive. So you can just say x is more than 0. You can type all the symbols. If you're using your emulator, you can use your computer to type all these symbols. So the value that is more than 0 will be this value. All right. Any question before we move on to the next thing?
Sir.
Great. Okay. Yeah.
Sir, I have only one question. So we are giving the upper value for finding the second solution. Is it not possible to define the lower and upper value in the same expression itself?
Yeah, of course. You mean inside the bracket?
Yeah, exactly. Inside the bracket.
Yeah, see, you can do it here like we did it 1 comma 1.5. So you can define lower and upper both. So you get a solution or the solution between these two.
In such a cases, both the solutions will be printed?
No, one solution. Now, if there are two solutions between 1 and 1.5, then the one that is closer to origin will be shown here.
which is closer to the lower limit, that will be present.
Yeah.
Okay, thank you, sir.
Okay. Another way, I hope everyone has access to questions now. Anyone still doesn't have questions? Okay, there are some questions here. Questions in test mode for student will both Nsolver and Polyroot. Yes, definitely, they both are available. Polyroots and Nsolver are available in test to test mode. Okay, great. Okay, moving on. Now, arithmetic and geometric series and sequence and series. It seems that we don't, my experience is we don't use much of graphic calculator in sequence and series, except when solving to find a specific term using logarithm, we use basic calculator. Otherwise, we don't use calculator. Now, how can we effectively use a graphic calculator? By graphic calculator, I mean this TI Nspire CX2. How can we use it effectively? So I'll open a new menu. Sorry, doc. I'll insert a new problem here. Now I'm in the second question. I'll add a calculator. I see a new. Okay, let me try putting that worksheet again. Otherwise, what I can do is, let me try it one more way. Let me take a screenshot and see if it works this way. Copy. And paste. Otherwise, we can do one more thing here. So I'll open a new page, that is my notes page. And in notes page, I can hold on, give me a sec. Okay, I just shared a screenshot. Try if you can open this. So this is the question. Those who cannot open, can you see on my screen? Consider the arithmetic sequence 2, 5, 8, 11, and so on and so forth. Find the nth term of this sequence, part A. Write down first 20 terms of the sequence. Find the sum of 30 terms of the sequence, and which term of the sequence will be the first 3-digit number. How many terms should be taken for the sum to exceed 129? It was just a random question. I just wrote this. So how can we effectively use a graphic calculator in this question? 2, 5, 8, 11. So obviously your nth term will be A, or say first term U1 plus n minus 1 times D, where D is 5 minus 2, that is 3. The first thing I would like to do here is, I would like to define my UN. And we all know that to define, we use this button next to 9 with shift colon is equal to. If you're working on with your emulator, you can just type colon is equal to, and that will define. So UN we are defining as first term is 2 plus n minus 1 is 3, or n minus 1 times D is 3. So 2 plus n minus 1, so it will be 2 plus a bracket n minus 1 times, make sure you write multiplication times 3 and just enter. So this is your nth term that you have defined. Now, if you go to the first question, First question is find the nth term of the sequence. So you can just simplify it and it will be 3n minus 1, right? Next, write down first 20 terms of the sequence. Now this is very interesting. Out here, we can just type either in the computer or calculator, just type sequence, S-E-Q, S-E. You see again, it's italic, but the moment you type Q, S-E-Q, it has become null point, means it has some meaning. Sequence, a bracket, we have already defined nth term, so UN is your nth term, and U is bold, means it has a meaning, UN. Then you define what is your variable here, N. Now, you need to write down first 20 terms, so just press 1 and then 20. And what happens is, you get first 20 terms of this sequence. So these are first 20 terms, 2, 5, 8, 11, and so on and so forth. So write sequence, bracket, nth term, comma, the variable, comma, term number, from which term to which term. Now, if you're not interested in first 20 terms, you just want to find, say, last 5 terms. So just type from 15th to 20th. So these are last 6 terms. So these are last 6 terms. So this is how we can effectively use this graphic calculator. Sometimes they say, okay, fine, write down these terms, and then you further process these terms. You don't really need to do those heavy calculations. Just type it in your calculator and you get your terms. Now, find the sum of first 30 terms. Next part of the question is find the sum of 30 terms of this sequence. To find the sum of 30 terms, what you can do is, again, the syntax is sum, S-U-M, sum. Whose sum would you like to find? I would like to find sum of the sequence that I defined as UN. So sum, sequence, UN, and then if you would like to find sum of first 30 terms, then 1 and 30. So 1 and 30 and enter. So 1, 3, 6, 5 is sum of first 30 terms. Now, if you do this in exam, I would say it depends on how many marks this question carries. If it carries 2 marks, 1 mark, 2 mark, use the calculator and just say by using calculator, this is the sum. But if it is 3 mark, 4 mark question, then you're expected to show some working, at least the formula. The formula is in data booklet, and students can write formula. They can mention what is first term, what is n, what is comma difference. Hence, this is the answer. So can find sum of any like n terms, 1st to 30th term, 7th to 18th term. Again, we just need to change this range 130 and they get it. Next term is which term of the sequence will be first 3-digit number. So if you see 2, 5, 8, 11, if you go on the same fashion, which term will give you first 3-digit number? So we usually say let UN nth term is equal to 100, first 3-digit number. We find the value of n, and on the basis of the value of n, we decide which will be the term. So basically what we need to solve is UN is equal to 100, right? So how can we do this? We just did in previous page here, nsolve. So we can effectively use nsolve here and solve. What are we solving here? Oops. And solve UN U bracket n is equal to 100. UN is equal to 100. And what is your variable here? N, and enter. So you get 33.7. So which term will be first 3-digit number? First, that will be 34th term. So you can check the validity of your answer. If you find N32, it will be a 2-digit number. And if you find N33, it will, 2-digit number. So more than 33.7 will be 34. So 34th term will be 101. So this is how we can quickly check answers also on the spot, and we can use these comments Usually when they ask find 10th term, 13th term, or which term will be more than 100, less than 100, these questions, they don't carry many marks, maximum 2 to 3 marks. So using a calculator is justified here. The last part of this question is how many terms should be taken for the sum to exceed 129? So I'll leave this part for you guys. So what you can do is sum to exceed 129. In this case, you can do n solve with sum. So your syntax will be n solve. Maybe everyone would like to try it quickly. And solve, just scroll up, copy this, paste it here. So this is sum of n terms. So you will do n1 comma n, sum of n terms. And this is equal to 129. Take care of bracket. This bracket is here. This one is for that, is equal to 129, comma n. And your answer will be, when it says sum to exceed 129. So when you write 129, your answer will be a whole number here. So let's say this is 9. It means 9th term will be equal to 129 or it will exceed 129. So the answer that you get here is more than or equal to 129. So for example, out here, your answer is 10. So sum of 10 terms will be either 129 or more than 129. So this is how we can use this graphic calculator for this thing, arithmetic sequence. We can also use this for geometric sequence. Before we move on to geometric sequence, any question quickly?
I have a question.
Yeah,
in the last portion where we are finding the sum of a set number of terms, okay, in the last step that you did, could you please explain why we changed, why we did un, n, 1, n?
One moment. Sorry, why we did un, 1 and this one? Sorry, could you please repeat?
Yes.
Okay, now the question was, how many terms should be taken for the sum to exceed 129? So we are talking about the sum of the terms. That is why we are taking sum here.
Okay, I want to know why we have n, comma 1, comma n.
Because nth term and sum of n terms, we are we are finding sum of n terms is equal to 129. So first term, when we say sum of n terms, if we always start from first term till nth term, this sum is 129.
All right, okay.
Yeah.
And then we're finding the answer. All right, thank you so much.
Okay, let's move on. There is a question on geometric progression. So I will just open a new page here, problem here, and add notes, and I will get you this question here. So insert image. Okay, this is the next question. Those who have access to this one, the PDF, they can see, otherwise you can see here. The sum of first n terms of a geometric sequence is given by Sn is equal to summation sigma r is equal to 1 to n 2/3 7/8 raised to the power of r. Find the first term of the sequence and find sum to infinity. Then find the least number of n so that S infinity minus Sn is less than 0.001. And I think this question is from November 21 HL paper 2. AA HL paper 2, time zone 0, November 21. So how do we do this with the calculator? So again, it's very simple. What I'll do here is I'll open a new page here, a calculator page, and I will define Sn as summation r is equal to 1 to n, 2 by 3, 7 upon 8 raised to the power of r. So let's do it. And if you have your calculator, please do it together. Sn is defined as summation. Where is summation notation? Next to 9. This button has all these templates. R is equal to 1 to n. R is equal to 1 to n. Now be careful about one thing here. We are using R is equal to 1 to n, and this is a geometric progression. So if you use the common ratio later, then do not define that common ratio as R. Maybe you can use RR or CR, something, but not R, because R is already here. When I was working on this, I had this trouble. So one of my friends, we worked together to solve this. So 2 by 3, 7 upon 8 raised to the power of R, 2 by 3. So this is 2 by 3. And you put another bracket here, 7 upon 8 raised to the power of 7 upon 8 raised to the power of R. You put a bracket, division, 7 divided by 8 raised to the power of R. So you can R and define it. So you have already defined Sn. So sum of n terms is here. So let's go back to question and see. Find the first term of the sequence. So first term is actually sum of one term. So if you write S1, that will be your first term. So S1 variable is not defined. Okay, so why do we have problem here? Sn r is equal to 1 to n, 7 upon 2 by 3 times 7. No idea why is it like this. Okay, probably what is happening here, you know, summation, only this thing is inside this one. So we have to put another bracket here to redefine this. Put another bracket. So what your computer is most probably is understanding is summation of 2 upon 3, a separate term, times 7 upon 8 raised to the power of r. So we put a bracket here and we close the bracket here. Now will it give us S1? Okay, so let's redo this. So I'll quickly define this again. Oops, sorry for this. Sn, let's do it again. Sn defined as Sn is equal to summation. Summation is here. Summation r is equal to 1 to n. R is equal to 1 to n. And here you put a bracket. In this bracket, I'll put another bracket in this bracket, 2 upon 3. So 2 divided by 3. Writing correct bracket is very, very important in a calculator. And 7 upon 8, 7 divided by 8. And only 7 upon 8 raised to the power of r. So raised to the power of r. And it is done. Now when we find S1, yep, we should get the answer. So S1 is sum of first term. Sum of first term is sum of one term. Sum of one term is, yeah. There are some messages. Great. So S1 is sum of first term, right? Now, next part of the question was find sum to infinity. For sum to infinity, it is first term divided by 1 minus common ratio. So what we can do is 7, instead of writing 7 upon 12 again and again, we can store this. So we can go to second, store, and you can write it as U1. U1, that is your first term. So this has been stored as 7 upon 12. Now, common ratio will be second term divided by the first term. First term is this one. And second term, how do we find second term here? Second term will be, or we can straight away find the common ratio. Common ratio will be, second term is sum of two terms. So sum of two terms minus sum of one term divided by sum of one term. That is your first term. You get 7 upon 8. So this is your common ratio. Now, if you store it as R, this conventional notation R. So since you already have a R, so there will be a conflict between variables. So what do? We can save it as some other variable. So I'll store it as maybe RR. So RR means 7 upon 8. So when you're asked to find in the next part sum to infinity will be simply first term, that is U1. So first term is U1 divided by 1 minus common ratio. So 1 minus RR, and that's your answer, which is 14 upon 3. Sounding good? Great. Now, this is sum to infinity. And third part of the question is find the least value of n such that sum to infinity minus sum of n terms is less than 0.001. So how do we do this? Let's save it as something. Maybe you can save it as store as t. So now t is sum to infinity. Just remember it. The next part of the question, find the least value of n such that s infinity minus sn is less than 0.001. So this is an equation, and of course this will have only one answer. So we can use nsolve or bracket. S sum to infinity is t. So just write t minus sum of n terms. We know sum of n terms was Sn. So t minus Sn. It has to be less than 0.001. So for this to be less than 0.001, we can assume this is equal to 0.001. 0.001. And what is your variable here? N. So when you enter, your answer is 64. It means when you take 64 terms, your answer will, the difference of these answers will be 0.001. So the least value will be 64. So this was a 6 marks question. And if we use graphic calculator effectively, I think we can do this in maybe 2 minutes, maximum 2.5 to 3 minutes. So this is how we can use the graphic calculator effectively for questions that involve geometric progression. Before I move on to the next question, that is, okay, one more thing. This question, if you want, you can do with the help of a graphic calculator. I mean, graph also. How can we use graph to do this? Just find the difference. Let me show you how can we do this with the graph also. So let's add a graph. In the graph, since we have already defined t, we already defined Sn, so you don't need to define anything again. Just write t minus Sn, t minus Sn. Create a slider for n. No, let's not create a slider for n because it reads fx, so make it sx here. Change the variable to x now. So t minus sx. You get the stepped graph. Why do we get the stepped graph? Because then cannot take all the values. It is the geometric progression. It can take only countable values like 1, 2, 3, 4, 5, and so on. So the best way to do this, you can do it with the help of intersection part. Otherwise, what we are looking is this sum to be less than 0.001. So just get the table. Control L will give you the list. Sorry, T. Control T. Control T will open a list here. So in this list, you can see what is happening here. These are the values of T minus Sx. So just keep scrolling till you see a value that is less than 0.001. Now, if you see out here, you can move this. Or when you move your cursor on any of these boxes, the actual value will be here. So we can see it is more than 0.001. If you scroll further down, it is less than 0.001 because it is 0.0009, right? So 64 is the answer. So you can check, and if any of your student is using TI-84, we can use this very effectively using the table property. So we can use NSolve and these tables. This is how we can solve. Any question quickly before we move on to the next question? We don't have much time left. I can see we have using NSolve. What if we had got n as a decimal number, then we round up or down? So when it says how many terms should be taken for the sum to be less than this. So obviously, if you take a bigger number of n, sum will be bigger. So we have to decide this according to the question. So what is your answer when you use NSolve? See, what we are doing is another thing here is S infinity minus Sn. So minus Sn, so you have to overestimate this. You always have to round it up. If your answer is, let's say 63.57, your answer then make it 64. Yep, great. Okay, let's move on. We have very limited time. Okay, moving on. I'll insert a new problem here. Next is a notes page here. Now, next question is from May 22. This May 22 exam. It is on financial mathematics. It says Sam invests $1,700 in a saving account that pays some interest rate. Let me get this question for you so that we can all read this together. Let me insert an image here. Okay, this is the question. Sam invests $1,700 in a saving account that pays a nominal annual rate of interest of 2.74% compounded half yearly. This is very important. Sam makes no further payment to or withdraws from this account. Find the amount that Sam will save in this account after 10 years. So this is again very, very powerful tool in Nspire. So let's open a new calculator page, Control I, and add a calculator page, go to menu and finance solver. In finance solver, N is like number of payments or number of years. I think we all know about these N, I, P, V and all. So in context of this question, what will be our N? N is, the question is Sam invests $1,700 in a saving account that pays a nominal annual rate of interest of 2.74% compounded half yearly. He makes no further payment after 10 years. After 10 years, we can do this in two ways. If you put 10 here, 10 here, and what is I? I is 2.74, so 2.74. And PV is the present value. Now, since Sam is investing, so the money is going away from him. So this will have a negative value. So it will be negative 1,700 to negative 1,700. 0. PMT, there is no payment, so we are not looking at that. Future value, we have to find, we can leave it blank. And what happens here to PPY and CPY? PPY is 1 and CPY will be 2 here because it cumulates twice in a year. So CPY will be 2, but the payment is calculated once. So PPY is 1, CPY is 2. Then future value, go to future value, put your cursor here and enter. You get 2231.71. So find the amount that Sam will have in his account after 10 years is $2,331. What if you decide to calculate this twice? Because since it is compounded half yearly, so after every 6 months, if you like to calculate the interest, then you can make it 2. In that case, your N will be now 20. You have to take same unit for number of payments and number of years. N is actually number of payments. So when you enter, you get the same answer. So if N is 20, PPY will be 2. Twice in a year. If you would like to keep it 1, then make it 10, and you'll get the same answer. Somebody has sent a message here, N is equal to 20. Yep, you can use N is equal to 20 or N is equal to 10. They both work. Okay, moving on. Next part of the question is find the value of, David also invests 1,700 in a saving account that pays an annual rate of interest of 4% compounded yearly. Now this is compounding every year. David makes no further payment or withdrawal from this account. Find the value of R required so that amount in David's account after 10 years will be equal to the amount in Sam's account. So this is what Sam has earned in 10 years. So keep it FY. So find the value of R. You need to find value of R. And N is 10 years again, so just keep it 10. 10, and you can keep 10. I we have to find, so we can check on this later. David is also investing 1,700, so negative 17, no further payment. And it is compounding once in a year, so 1, 1, go to R, where R means I, and enter. You get 2.758769. You can round it off to 3 significant figures, 2.76. Part C of the question, we still have 10 minutes. Part C of the question is find the interest David will earn over 10 years. So he invested 1,700 and his final value is 2231. So we can just subtract 2231 minus 1700. So rounded off value will be 532. So again, like we all know that we can really effectively use Finance Solver. Any question before we quickly move on to the next question? Great. I have a few more questions. So I think we will be able to do just one more question after this. Let's see if we can do more questions. Now, when it comes to binomial theorem, how can we effectively use binomial theorem here? So there are 2 questions here, and I would like to do, let's do this one. Consider the 4th question. Consider the expansion of 3 plus x squared raised to the power of n plus 1, and the coefficient of x raised to the power of 4 is given. Well, let's do the last question. It is slightly, it has better level of usage of calculator. Okay, so those who already have this, great. Who do not have access to this question, let me insert it here. So I'll insert the image. This image is here. Oops, this is very small. Okay, this is in the expansion of 2 plus b raised to the power of n. the coefficient of b cube is 4 times the coefficient of b squared. So find the value or values of n. In 2 plus b raised to the power of n. In 2 plus b raised to the power of n, this is 2 plus b, a bracket raised to the power of n. In the expansion of this, the question is coefficient of b cube is 4 times the coefficient of b squared. So what will be the coefficient of b cube here? It is obviously NC2 b cube. So it will be NC3. So it will be NC3 and 2 raised to the power of n minus 3. 2 raised to the power of n minus 3. And the coefficient of b squared, it will be NC2, 2 raised to the power of n minus, 2 raised to the power of n minus 2, right? So when we have to find the value of n if the coefficient of b cube is 4 times that of b squared. So how do we do this? Same way, we go to this beautiful app that is called Nsolve, calculator, menu, algebra. Let's go to numerical solve. In numerical solve, we write NCR. NCR is in menu, probability, and combination. So NCR, it is n comma 3. So n comma 3 times 2 raised to the power of times 2 raised to the power of n minus 3. So we just write n minus 3. And this is equal to 4 times. So 4 times is here. You can copy this here straight away and paste and make it NC2 and to the power of n minus 2. And out here, you can go out. Now, what is the variable here? Variable is n, so I can write n. Now, when you solve it, there might be many values. So if you do not write anything here, your answer is 0. But we know that n cannot be 0. N has to be a number more than 0. So what we can do is we can put n comma 1. Or yeah, n comma 1. So number has to be more than 0. So this is 1. 1 is another answer when you solve it. Now we know that we are finding NC1, NC2 means we are making a selection of 3 objects out of n objects. So n cannot be 1 also. So we can quickly move on and make it more than 1. So actually we need more than 3 or more than 3. So more than 3 when we do, n is equal to 26. So 26 is the correct answer here. Hopefully 26 will be the value of n. So that coefficient of n cube, b cube is 4 times the coefficient of b squared. So for that, the value of n has to be 26. And if those who have additional calculator, that is TI-84, you can do this in the table. You can draw the table and check how it works.